So in this section of the notes, we're going to unpack two different ways to describe sequences. We have the ability to write sequences as an explicit equation or a recursive equation. So in the previous work in practices 5 through 11, you were looking at explicit definitions of sequences or equations that represented sequences in an explicit way. So when you have such equations, they're equations of sequences that are represented with a formula that lets us find any term in the sequence without knowing any other term of the sequence. Okay, basically what that means is I have a nice equation that's something along the lines of that a sub n equals 2n plus 10, and I can very easily calculate a sub 98, right? All I need to do is plug in 98 for n and do a little bit of simplification, and I have my 98th term of my sequence. However, this is not always how sequences are represented, and we kind of played with this idea of recursion initially when we looked at building or identifying the patterns between terms in practices 1 through 4, right? If you'll remember, in our very first practice of these notes, we had the sequence 1, 4, 7, 10, and we were looking at a pattern amongst all of these terms, right? And we kept saying things like, oh, I'm adding 3 to the number before. So when I look at things recursively, I'm defining terms of the sequence by describing the relationship between its successive terms. Okay, so that means we're looking at things recursively. If I need to know about previous terms to figure out my current term, I'm looking at something recursively. So recursive sequences define the nth term of a sequence as a function of the previous term. Okay, if the first term of the sequence is known, then the recursive formula can be used to determine the remaining terms. So it's something along the lines of I start at 1 and then I add 3. I get 4 and then I add 3. Okay, but if I only had that sequence of terms 1, 4, 7, 10, if that's all I had, and I was then asked here to calculate the 98th term, that's going to be pretty tricky, because in order to figure out the 98th term, I would need to know the 97th term. But in order to figure out the 97th term, I would need to know the 96th term. And unfortunately for us, in this situation, we only have up until the 4th term of 10. Okay, so that's going to be a pretty difficult task to go ahead and calculate the 98th term given this information. I really like this analogy of a ladder when thinking about recursive definitions of sequences. Okay, it says to get to the 3rd rung of a ladder, you must step on the 2nd rung. But to get to the 2nd rung, you must first step on the 1st rung. So each rung of the ladder depends upon stepping on the rung below it. Okay, and that's kind of the idea here with recursive sequences. To get to the next term, we have to look at the one that was before. So we're going to go ahead and look at some notation really quickly before we look at an example. So here, we have the notation, this is pronounced a sub n minus 1, and that means we're looking at the term before the term we are currently on. Okay, so in our example up here, 7, if I'm looking at 7, the a sub n minus 1 term, the term before that, would have been 4. A sub n talks about the current term. So if I'm focusing on 7, a sub n, right, that would be 7 in this case. Versus a sub n plus 1 is talking about the next term. If we're looking at that sequence in red, that 1, 4, 7, 10, and I'm focusing on 7, my next term would be 10. Okay, so we're going to kind of play with this idea in this next example. I'm going to show you how to write this out with a lot of great mathematical notation, and then I'm also going to just kind of talk through it so you can kind of see two ways to approach this. So we're asked to find the first four terms of the sequence a sub n equals 3a sub n minus 1 and then plus 2. Okay, so it's important to understand that because of this notation right here, this a sub n minus 1, we're looking at a recursive definition, okay, or a recursively defined sequence. So what this means is it says, okay, your current term is, right, that's what our equal sign represents. Our current term is equal to 3 times our previous term, and then plus 2. And we start this at a sub 1 equals 5. So 5 is our starting point. Okay, so just to kind of clarify a little bit what's going on here, we have our current term. If we're going to find any term in the sequence, we need to know our previous term. We need to multiply it by 3, and then we need to add 2. Okay, so taking our previous term, multiplying by 3, and then adding 2 is going to get us all of our terms of our sequence. So I'm going to again show you this with some pretty detailed mathematical notation, and then we're going to kind of talk through it logically. So I already have a sub 1, so we're off to a nice start. We have a sub 1 equals 5. If I want to figure out what a sub 2 is, I need to replace every single n in that equation with 2. So a sub 2 would be equal to 3 times a sub 2 minus 1 and then plus 2. I can simplify that to see that this is just 3 times a sub 1 plus 2. Well, remember, we were given our a sub 1 term, right? We were told that a sub 1 equals 5. So instead of writing a sub 1, we'll go ahead and write 3 times 5 and then plus 2, right? So all we've done is a substitution of that first term. And that calculation tells us that a sub 2 is equal to 3 times 5, which is 15, plus 2, which is 17. Okay, so we have our second term here. To calculate our third term, so I'll go ahead and box that just so I can see it very clearly, as I'm going to need it here in a minute. To find our third term, we substitute 3 in for n, and that will give us 3 times a sub 3 minus 1 plus 2. Doing a little bit of simplification, we see that that's really just 3 times a sub 2 plus 2. And then again, we're going to rely on the fact that we know a sub 2. We found a sub 2 to be 17. So instead of writing a sub 2, we're going to write 3 times 17 and then plus 2. So again, we've just made that substitution using our previous term. And that tells us that a sub 3 is equal to 53. The directions tell us to find the first 4 terms, so we're almost done. We're going to go ahead and to find a sub 4, plug 4 in for n. That gives us 3 times a sub 4 minus 1 and then plus 2. That gives us that a sub 4 can be found by taking 3 times a sub 3 plus 2. And here again, we'll rely on the fact that we know a sub 3, right? A sub 3, we calculated that here. A sub 3 is equal to 53. So instead of writing 3 times a sub 3, we're going to write 3 times 53 plus 2, and we find that a sub 4 is equal to 161. Okay, so the answer to our question, the first 4 terms of a sub n equals 3 times a sub n minus 1 plus 2, where a sub 1 equals 5, those first 4 terms are 5, 17, 53, 161. And I'm going to go ahead and not write the ... because I was asked for 4 terms and I'm giving 4 terms here. Okay, so I just want to talk through this logically, right? We don't need to, if that notation was a little overwhelming, that's okay. We don't necessarily need to use it. We know that a sub 1 again equals 5. We are told that a sub 2, we're supposed to take our previous term, which is 5, multiply it by 3, and then simply add 2. Doing that calculation again gives us 17. If we want to figure out a sub 3, we're supposed to take our previous term, well, our previous term in this case was a sub 2, which is just 17, and multiply it by 3, and then add 2, and that gives us 53. Lastly, to calculate a sub 4, we're supposed to take 3 times our previous term, which is 53, and add 2 to that, and that gives us 161. Okay, so without substituting in the n and cleaning up our subscripts, we can still manage to figure out this these first 4 terms, right? We're plugging in every single time our previous term, right? So when we calculate a sub 3, we need to plug in our a sub 2, and when we calculate our a sub 4, we need to plug in our a sub 3. But you'll see with a little bit less work that we still get those first 4 terms, okay? But I think it's important to have comfortability with the notation. I think it helps us understand what is really going on here. But just come back to whatever you kind of unpack as far as what the sequence is telling you to do. So before I leave you to work on practices 12 through 15, I just want to quick talk about what does 12 mean. 12 tells us that to find our current term, we need to take 2 times our previous term, and that is starting at, right, we have to start with the value of 3. Okay, so I'm going to go ahead and leave this to you. Make sure that you're checking the answer key and letting me know if you have any questions about using the recursively defined sequence in 12 through 15 to write the first 4 terms of the sequence.